Hi, this is Dr. Nick with the ECG Academy, and this video talks about timing, amplitude, and rate measurements of the normal ECG. This is Chapter 2 in Section 6, and we're going to basically get into these little tiny boxes and what they mean. Well, this is an ECG, a normal one from an 18-year-old. It's about as normal as it gets, but let's look at a high-resolution scan of this cardiogram. All right, now on this scan, you can see that there is this grid here. There are these heavy lines moving across, heavy lines moving up and down, and they create this these squares, large squares. But within each large square, there are these small squares. The ECG is based on the metric system, so one small square is 1 millimeter high and 1 millimeter wide. Remember, there's about 25 millimeters in an inch, just so you guys have some reference here. And so you have these 1 millimeter boxes. Now, the ECG machine that's printing out a standard size ECG will use this measurement. That's 10 millimeters per millivolt. Remember that milli in the metric system means 1,000th. So one of these is a millimeter, which is 1,000th of a meter. And it says 10 millimeters per millivolt. So if you count up 10 of these, that's 2 large boxes, because each large box is 5. So you have 10 millimeters here. And that's equal to 1 millivolt. Remember, that's 1,000th of a volt. It's a very small number, isn't it? But, of course, we're measuring the heart's electrical activity through the skin and the bones and the muscles, so we're only seeing a little tiny electrical signal. If we actually measure this, all right, so this is a QRS complex. Remember, this is a P wave, and here's a QRS complex. And this one lands on the baseline, so let's measure 1, 2, 3.5 little boxes. Well, what's a little box? If 10 little boxes is equal to 1 millivolt, then one little box is equal to 0.1 millivolts, or 1/10 of a millivolt. Multiply that times here, 3.5, and you get 0.35 millivolts. That's a really tiny QRS complex, isn't it? All right, so that's how high they are. Now, how do we know? Do we have to look for this number? Well, you can actually see this thing. It's called a standardization pulse or a calibration pulse. And it happens to be 10 small boxes high. That tells us that the ECG machine is putting out a standard size. If you needed to have a larger tracing, let's just say if the signals are really small and you wanted to see more detail, you could push a button or turn a knob on the ECG machine and increase it to 20 millimeters per millivolt. The standardization pulse will then look this big, and the ECG will be twice as large as it otherwise would look. So that's how you can tell what your standardization is. You can look at this calibration pulse here, or you can look at your standard here. The other thing you need to know about is timing. If it's running the paper at the standard speed, then this should be 2 small boxes wide. On the paper, if you look down at the bottom someplace, there'll be something that says this, 25 millimeters per second. Well, that tells us how fast the paper is running. So remember, 25 millimeters is 25 small boxes, so 5, 10, 15, 20, 25. So from here to here is 1 second. So we can split this up and we can say, okay, well, if that's 1 second, then one large box is 1/5 of a second, isn't it? Because there's 5 of them in a second. And if you drill down and look at one of these tiny little boxes, it's 1/25 of a second. Well, to tell you the truth, most people don't really like to use fractions. And I think decimals are much easier to understand. But what's even easier to understand are milliseconds. Well, especially electrophysiologists who deal with ECGs all the time, they deal in milliseconds because it tends to be a little bit easier. The numbers, they're whole numbers, they're not fractions or decimals. Well, what's a millisecond? Since 1 second is made up of 1,000 milliseconds, after all, milli means 1,000th, doesn't it? So that 1 millisecond is equal to 1,000th of a second. All right, that makes sense. So that means if there are 1,000 milliseconds in 25 boxes, if we divide 1,000 by 25, that gives you 40 milliseconds. So that means that one of these little boxes is 40 milliseconds wide. And a big box is 5 little boxes, so that's 200 milliseconds wide. That becomes very important in the next chapter because we're going to be making measurements of all these little waves and everything. But for the time being, let's stick with the big picture. Because in reality, the first concept you have to think about is rate. How fast is the heart rate? Well, that's precisely the topic of the next video. So go watch it, will ya? This is Dr. Nick from the ECG Academy, signing off.